Welcome. In this section, this is going to be our third and final PowerPoint tutorial. This is section 8, and we're going to talk about firewalls today. Firewalls really sound a lot more complicated than they really are, so it's something that you don't have to really stress yourself out too much. So what you're going to be doing here is looking at the different types of firewalls and things like access control lists and network ports and tables and things of that nature that all make up exactly what a firewall is. So again, we have the common denominator is access control list and the network ports and the IP tables. And the access control list really are what makes it go. And these are basically the rules that you have. Just like if you have group policy in Active Directory, you're going to have lists that contain who can do what. And so we're going to talk about each and every one of these things. And hopefully when you get done, you'll have a very good understanding of how a firewall works. Just remember that this is just a summary of what goes on in firewalls. For complete information, you're going to want to watch all the videos. They really do a great job in explaining everything in major detail. So again, we have firewall, and it's either going to be software based or it's going to be hardware based. Remembering that each one has a specific purpose and there are advantages and disadvantages to each and every one. Its main purpose is to protect attackers from gaining access to the network. However, firewalls are also used to block access, especially if you have a business or you're in a school where things need to be really truly secure. Especially a school, you need to block things like pornography, gaming, any kind of things that go against the rules of Child Information Protection Act, that you must make sure that the students are surfing the internet. For businesses, you want to make sure that things cannot be done, and a lot of times you don't want company being used to do personal business going on to Amazon or whatever those sometimes are blocked. So parents and or rather for employees cannot use that time to do their own personal shopping. However, that can lead to other issues where there are little bit times you have to go into Amazon. So all these things are done in access control list. So again, we have two types of implementation. One is going to be hardware, one is going to be software. Hardware is much better. You have one hardware appliance and it's used to protect the entire network. You're just going to put it on the outside where your DMARC is, and that will be everything on the inside has to be going through the firewall to get to it. Everything on the inside has to go through the firewall to get out of it. So there's nothing in between. It's obviously more expensive, but it does give you the best protection. Software, on the other hand, you just put it on one computer. You can actually use the Windows firewall that comes with Windows 10. It's much less expensive, especially since it's usually free, but it's not as effective as hardware. Plus, it needs to be configured on each machine. So we have the network-based firewall again. It sits on the edge of the network. It acts as a barrier between the network, and it does filter all traffic that comes from the internet, but it also can filter traffic going out. And again, it's usually hardware. This is what it looks like. So you have your little network. It has the 4 computers, and then you have a firewall, and then you get to the network. So a host base is just going to protect one single device from unauthorized connections. So here we have an internet, and we have a software base that's for this computer up here. It has nothing to do with firewall. There's no real protection. So be very aware. It does exist. It does work, but be very careful about how you implement that. Again, access control lists are the heart of what your firewall works. So it's going to specify what traffic is allowed through and what traffic is going to be blocked. It's going to scan it, both incoming and outgoing, and it takes a set of rules. Are you allowed to go here? Is this person allowed to come here? Can you go out on this port? Can this person do this? So you have to do that. And if it looks at everything, if it fails one, then the rules are going to be denied, and nothing's going to happen. So here we have sales, we have engineering, and we have marketing. So each one's going to have a specific set of rules that are going to be set up. Everybody has to go through the internet well, then you're going to have to go through the firewall to get there. And then you're going to be determined whether or not you can go to a specific site or whether or not you can go out there. You can also block it during certain hours for people. So here you have access ACLs that are going to restrict network access. It can block subnets or networks, and it can block hosts using port numbers. So here you see 8443. 80 is HTTP. 443 is secure HTTP, or you have the HTTPS. When you go on a website and you purchase something, you better make sure it says HTTPS and you have the little lock sign up there. 20 and 21 are for FTP. So these are the ports that you can open up or you can block. If you don't want to do it, you're all set. So the first rule is to permit all surf. Now that can have a major implication that you're not really sure of it. Then the second rule is deny sales from surfing and place specific rules at the beginning and the broad rules at the end. So the second rule really should be first, because it will never get to the second rule if you're going to permit everybody to surf. So you have to use those in proper order. Now we have network ports and their logical connections that are provided for TCP or UTP and a transport layer. We did the OSI layer protocol, so you know how that works. And then packet filtering. So what packet filtering does, it simply operates at layer 3, and then at layer 3 the packets are compared to the rules, and you're either going to allow it to come in or you're not going to allow it. There the source and destination IP can be examined, and also a source and destination port can be examined. Remember we talked about NAT and how it has ports in here. Well, if a port is open, it's going to get to that particular place. So the NAT is going to automatically open up that specific port for that session and then close it when the session is over. Then we have an implicit deny. Everything is going to be denied unless it's explicitly allowed. So you're going to have, you're allowed to do this, you're allowed to do this, you're allowed to do this. If you don't meet any of those rules, you're not getting out. So here we have the packet filtering over here again. So it's looking at the network layer in here to see what's going on here. Then remember the packets actually are distributed in the transport layer and the data link layer over here before it gets to the physical layer where it actually goes out in the internet. So this is where the circuit level gateways work, and they're going to filter traffic out based upon a session layer and not the IP. So that's totally different. So let's take a look at that. And you can see it filters it based upon the session, and it uses the three-way handshake where you send out a sync, the computer you're sending it out sends an acknowledgement with a different sync, and then you send out a sync acknowledging their acknowledgement. So basically it looks at the session D and whether or not the session is still active. Once it closes, the port gets closes. So here the firewall is only going to allow packets that match after the sessions, that match during that. In order to do that, the circuit level gateway is going to have to take advantage of the TCP three-way handshake, which we talked about over here. So when that happens, the server sends back with an acknowledgement, a sync ACK, which says, yeah, I have a session available, you can use it. Then the client responds with another acknowledgement called an ACK, which acknowledges that it received the original session information and wants to establish communications with the server. So here we have a layout of this. So you have the sync, acknowledgement, and then a sync acknowledge. And if all those things are peachy keen, then it's going to become active. So now we have application layer firewalls. And basically it just filters traffic based upon the application. Now we're not talking about Microsoft Word. We're talking about different types of applications. So you'll see that. It looks at content for specific words, such as games. So here is where it works. It's going to work at the application layer. And then you can see the session ID and the network are all involved in that. So here we're looking at HTTP and URLs. Proxy servers. Simple definition is it sits between a network and an end user. So for example, you may have a network of computers over here that need to access information on another part of the internet. So what you're going to do, the proxy server is going to sit between the internet and the clients. All the requests going to the internet from these clients are going to be intercepted by the proxy server. The proxy server will then take those requests and it's going to use application layer filtering to decide whether or not the request should be allowed or blocked. Being a proxy server, going through a proxy server is a very common way for people to try to avoid the firewall. So you have to be very, very careful of that. Then you have a reverse proxy server, which just does the exact opposite, hands requests from the internet back to the internal server. Here we have a unified threat management, just standard UTM. And what it does, it's all in one. It contains a firewall, VPNs, anti-spam, antivirus, and load balancing. Remember, load balancing allows a load to be distributed upon different routers so that everybody doesn't get hit at the same time. These are ports that you need to know. So I'm going to read them. 2021, that's your file transfer protocol. 22, SSH, that's secure. That's what you should be using if you're going over your network to communicate with a switch. Telnet will do the same thing using something like PuTTY. Just be careful. SMTP protocol, that is when you're sending out an email. It goes on 25. But however, remember, if you're using IMAP, you're going to probably be using port 465, a different port in there. Then you have a domain name service in here. That's when you type in Microsoft.com and your DNS server looks it up and gives you the IP address. DHCP is your dynamic host servers, and that's going to give an IP address out to a workstation when it goes on to the network. Trivial file transfer control, that's 69. HTTP, that's when you go out on the internet. 143 is IMAP 4. That is when your incoming mail is IMAP. It's either going to be IMAP or it's going to be POP3. One of the two. POP3 is 20. You'll see that in here. So 443, again, HTTPS. So configuring a firewall, turning on and off the firewall, obviously block incoming connections, allow incoming programs, and allow incoming connections. By default, if you try to ping something, ICMP is turned off, so you're not going to get the ping. You must turn that in. That's to prevent denial of services. So we have security appliances all in one. The benefits, obviously, all in one is expensive and less expensive than having to do 5 different boxes, requires little space, and it's good for one branch offer. You know, you've got the standard URL filtering, malware, spam, content inspection, and importantly, intrusion detection. So here's your design. The DMZ is when you have a web server in there. And of course, we talked about access control lists and a routed firewall. That's just nothing more than a firewall that allows ports to be hooked up to it and then network connections. So a demilitarized zone, it's really just nothing more than a buffer or for a subnet that sits in the private network and of an untrusted network such as the internet. And they're going to use filtering rules that can access control this to identify traffic will be allowed or blocked through a firewall. So it could be a layer 3 router. If not, it's going to be just a simple layer 2, but that's okay. You want the layer 3 really. So just be careful of making sure that your firewall is not connected to a layer 2 in order to give you an ultimate routing. You will not be able to route if you use a layer 2. So the next slide shows where web server is. And this is really something we want to set up as a demilitarized zone. We'll see exactly how that does. So here's your firewall. It sits on the outside to your web server and your internal network. However, you have to be very careful about that because they can get to the web server, they can get to the internal network. So you don't really want to do that. A boundary firewall here has another issue. It's going to allow anybody to get to the web server. It will protect the internal network, but it's going to allow, again, as I said, anybody to get to the web server. So here we have an issue, again, where we need to access an internal web server for drivers and downloads. So what you're going to want to do is you're going to want to place a web server inside the firewall. When outside users are able to access the web server, so you're going to have to open up ports 80 and 443. Those are HTTP and HTTPS. Now we have a problem. So it leaves the web server network open for attack because they're now open. So the ideal thing is to have the demilitarized zone. So you actually have 2 router firewalls or 2 firewalls specifically. One is going to protect the web server, so you have to get into the firewall just to get to the web server. Before you can even get to that, to the network, you have to go through the second firewall. So again, here's another setup. So the security for the web server is not as high as the security for the network. Again, they've opened up ports 80 and 443. So this firewall has 2 separate ports that can be used to route. ACLs we talked about, define firewall rules, can either allow or deny, can restrict access, but it can also block access to a specific host. Maybe you don't want something going to Microsoft.com. You want to block that. You can block that. So that's the end of this tutorial. I tried to do it as quickly as I can. Please remember, these are done in detail on all the videos that you'll find in section 8. Please let me know if you have any questions at all, and I'd be more than happy to assist you. Hope you have a wonderful, wonderful,